Hello everyone, I'm Marzia Patalikhani and I'm pleased to present my paper entitled Validation of an Elastic-ThermoViscoPlastic Constitutive Model for Clay in 20th International Conference on Soil Mechanics and Geotechnical Engineering. Dealing with structures built on foundations of soft clay is challenging due to time and temperature dependent nature of soft soil. Long periods of loading and changes in ground temperature could cause long-term creep settlements. Overstress theory of viscoplasticity proposed by Perzina in 1966 is the basic and the foundations of lots of viscoplastic constitutive models. There are different classifications of consolidation process of soft soil. One of them, which is more compatible with real measurements, is dividing consolidation process to instant or elastic deformation and delayed or irreversible deformation. The conventional consolidation component was primary and secondary consolidation, and it was proposed by Terzaghi. In 1967, Bejerum defined his time-dependent deformation using a series of parallel timeline. Using this definition, Yin proposed his viscoplastic model, and Kellen followed Yin's work and suggested his elastic viscoplastic constitutive model compatible with critical state soil mechanics. Then in 2016, Kers modified Kellen's work to consider the thermal effect in his model. The Kers model is an elastic thermoviscoplastic model. Here in this paper, the focus is to verify the Kers model by comparing the simulated result with the experimental measurements. Here is a schematic representation of Kers model. You can see the stress space and also the specific volume versus mean effective stress of the soil. The yield surfaces and the plastic potential surface is elliptical. So the size of yield locus is controlled by viscoplastic line, viscoplastic limit line. The viscoplastic limit line is parallel to NCL line with a constant distance between these two lines. T0 is starting time consider 24 hours after loading increment, and by elapsing time to the current time T1, the viscous deformation A0 B1 is occurred, and A0 B1 is a secondary or delayed compression line or creep deformation line. In this model, X, a specific volume with the index of X shows current specific volume of each strain status, while the index of M shows a specific volume corresponding to isotropic mean effective stress. The formulation of the model is presented in this slide. The strain strain rate is divided to two components of elastic and thermoviscoplastic model. Thermoviscoplastic term. The elastic term is the second formulation. Then the isotropic specific volume is the third formulation, in which the two first terms are viscoplastic, are a specific volume on NCl, and the third term is viscose term, which is actually the delayed compression line. Psi is the creep coefficient in Kerr's model, which is a function of temperature. And then the last equations shows the thermoviscoplastic component of strain rate. And the simulation is done by implementing the model, single element model in a spreadsheet, and comparing it with the measured experimental data. In this slide and the next slide, undrained triaxial test done by Creeley in 1996 is used. In this test and in this slide, the specimen is consolidated to 1.0 megapascal and then unloaded to 1.25 megapascal, which so the specimen is lightly over consolidated. The temperature here is constant to 27 degrees Celsius. In the in figure 3, the specimen is normally consolidated, and you can see the differences in measured data and also the simulated ETVP model. The model underestimates the peak deviatoric stress by about 15%. However, it overestimates peak pressure by about 20%. This slide shows a drain compression test, and the experiment used here is done by Qahramani Nejad in 2003, and the specimen here is done at room temperature, which is 22 degrees Celsius, and the specimen is normally consolidated with consolidation pressure of 0.45 megapascal. Here you can see the deviatoric stress versus axial strain, and also volumetric stress versus axial stress for both ATVP model and the experimental measurements. In this slide, the same test is done on under 75 degrees Celsius temperature. And the specimen is normally consolidated. You can see that we have a consistent behavior pattern of predicted and measured data for volumetric strain versus axial strain. However, simulated values of volumetric strains are considerably higher than measured experimental data. This is the references for this study, and I appreciate your attention.